All right, so this one gets a little bit tricky to work with, but let's just see if we can't figure this out. So if we consider that we have a U-tube, hello, you gonna draw or not? There we go, a U-tube, and it's filled with mercury right now. So it is, we're gonna assume level with mercury, okay? And then we're going to put some water in, and we're going to put some water in the left-hand side. And what that's going to do is that's going to push this mercury down over here a certain amount, and it's going to push this mercury up a certain amount. So what we're going to do is we're going to get water in here. Okay, we'll do water over here. And this mercury will have gone up to this point right here. Okay, so this is the X. This is the amount I'm looking for. But what gets really tricky here is that when we draw our line right underneath the water here, this is also X, because that's the amount the water pushed the mercury column down, X, and so this distance actually here is 2x. Okay, I know that's a little bit difficult. Again, this was here, and it went down a value of x. And this side went up a value of x. So this distance here is 2x. All right, it gets a little tricky there. So they're both open to the atmosphere, so I can ignore the atmospheric pressure. So I can just say at this point that the rho GH for the water, okay, this is the water side, has to equal the rho GH for the mercury. So it says that the water is 17.9 centimeters deep. So 1,000 times 9.8 times 0.179. And that has to equal 13,600 density of mercury times 9.8. Now how much did what's the mercury level? This whole thing is mercury. So since we drew our line here and we're saying the pressures are the same, this is going to be 2x. So twice the distance, okay? And when you solve this, you get that this distance is x. When you get x, it's 0.00658. But that's in meters. And you want it in millimeters, so that would be 6.58 millimeters.